versus nuclear fusion, the energy of the future. Introduction. Have you ever wondered how we can produce huge amounts of electricity without burning coal or oil? The answer lies inside the atom. Nuclear energy is one of the most powerful energy sources on Earth. Today, many countries generate electricity using nuclear power plants, which rely on nuclear fission. But scientists are also working on something even more powerful, nuclear fusion, the same process that powers the sun. In this video, we will explore how nuclear power plants work, what nuclear fusion is, and why fusion could be the energy of the future. What is nuclear energy? Nuclear energy comes from the nucleus of atoms. Atoms contain protons and neutrons packed tightly in the nucleus. When the nucleus changes, it can release a massive amount of energy. There are two main nuclear reactions. One, nuclear fission, splitting a heavy atom into smaller atoms. Two, nuclear fusion, combining light atoms to form a heavier atom. Both release enormous energy, but they work in very different ways. How nuclear power plants work. Most nuclear power plants today use nuclear fission. The fuel used is usually uranium-235. When a neutron hits a uranium atom, the atom splits into smaller atoms. This process releases a large amount of heat energy, more neutrons, radiation. The released neutrons hit other uranium atoms, creating a chain reaction. Inside a nuclear reactor, fuel rods contain uranium. 2 control rods absorb neutrons to control the reaction. 3 coolant, usually water, removes heat from the reactor. The heat produced boils water and creates steam. The steam spins a turbine, which turns a generator, producing electricity, just like in a coal power plant but without burning fuel. Nuclear power plants produce huge amounts of electricity with very little fuel. What is nuclear fusion? Now let's talk about something even more exciting, nuclear fusion. Fusion is the process where two light atoms combine to form a heavier atom. For example, hydrogen plus hydrogen, helium plus energy. This reaction releases an enormous amount of energy. Fusion powers the sun and all stars in the universe. But there is a challenge. To make fusion happen, atoms must reach temperatures of over 100 million degrees Celsius. At this temperature, matter becomes plasma, and scientists must control it using powerful magnetic fields. Special reactors called tokamaks or stellarators are used to try to achieve controlled fusion. One famous international project working on fusion is the ITER reactor in France. Fission versus fusion. Let's compare them quickly. Nuclear fission, used in current nuclear power plants, splits heavy atoms, produces radioactive waste, risk of reactor accidents. Nuclear fusion combines light atoms, produces much more energy, very little radioactive waste, much safer reaction. However, fusion is still experimental and scientists are still trying to make it commercially viable. Future of nuclear energy. If scientists succeed in building efficient fusion reactors, the world could have almost unlimited clean energy, less pollution, less dependence on fossil fuels. Fusion fuel like hydrogen isotopes can even be extracted from seawater, meaning energy could last for millions of years.